So welcome to this lesson, and in today's class we will be discussing scatter plots and residuals, and this is useful for your AP statistics exam. So what is a scatter plot? A scatter plot is a graphical display of a possible relationship between two variables, and when there is a relationship between two variables we graph x and y. And what does the scatter plot do? We try to determine whether the scatter plot can be reasonably explained in terms of a straight line. And this straight line is called the line of best fit. Now, when larger values of one variable are associated with larger values of a second variable, the variables are said to be positively associated. So this will be a strong positive correlation. As you can see, it goes from left to right, upwards. This is a moderate positive correlation, it's spread out. And this is a weak positive correlation, it's all over. If you look at this graph, there are some entries in black and some in purple. So this is a scatter plot where men are denoted in black and women by purple. And supposing we have in a scatter plot there are two clusters in this graph regarding where we are comparing potency with intensity. There are two clusters. For low and high intensities, there are different clusters. You can see that. So to describe a scatter plot, we need form, direction, strength, unusual features, and context. So basically remember form, direction, and strength. But a scatter diagram sometimes makes it difficult to judge the specific strength of a relationship. And this is where we come to formulas. So we have a correlation. Correlation helps to judge the relationship between two variables, and it is denoted by R. So R is given by 1 by n minus 1 summation x minus x bar by sigma x, y minus y bar by sigma y, where R lies between minus 1 and 1. Now, if mod R is greater than or equal to 0.8, we say that we have a high correlation. What happens if R lies between 0.5 and 0.8? Then we say that we have a moderate correlation. And if mod R less than 0.5, we say that the correlation is low. However, there are a few exceptions to this, as we will see. Now, we have the coefficient of correlation, and depending on that, we have the coefficient of determination, which is R squared. So if R squared equal to 100%, all the data points fall on a straight line. So basically, R squared measures the percentage of variability in the y values that can be explained by the linear regression model. So remember, R squared measures the percentage of variability in the y values. So coming to a question, the correlation between total points scored and age of players is R is 0.84. What conclusion can you draw by the coefficient of determination? So R is 0.84, so coefficient of determination R squared will be 0.84 squared, that is 0.7056, which is 70.56%. We usually write it as a percent. So you can say that of the 70.56% of the variation between total points and age of players can be determined by the linear relationship between the two. Now coming to the line of best fit. By a line of best fit, we mean the straight line that minimizes the sum of the squares of the vertical differences between the values and the line. So this is a line, and we have differences. The predicted values are y1 dash, y2 dash, y3 dash. So we are minimizing y1 minus y1 dash the whole square plus y2 minus y2 dash the whole square plus y3 minus y3 dash the whole square. And based on this, the predicted line is y equal to a plus bx, and b is the slope, which is r sigma y by sigma x, standard deviation of y by standard deviation of x. And this line of best fit is called the least square regression line or the regression line. So consider 3 points, 211, 317 and 429. If the line of regression of y on x is y equal to minus 8 plus 9x, find the sum of the squares of the vertical distances from these points on the line. So start with the points. When x is 2, when you substitute here, you get y as 10. When x is 3, you get y as 19. And when x is 4, if you substitute here, you get y as 28. So we subtract this with the sum of the squares of the original distances are, for y coordinates are 11, 17 and 29. So it will be the sum of the squares of the vertical distances will be 11 minus 10 the whole squared plus 19 minus 17 the whole squared plus 29 minus 28 the whole squared, which is 6. Now, there are some points to note. The difference between an observed value and a predicted value is called the residual. The residual of a point is the vertical distance of that point from the regression line. And residual is basically observed minus predicted. When the data point is above the regression line, the residual is positive. When it is below the regression line, the residual is negative. A positive residual means the linear model underestimated the actual response value, and a negative residual means the linear model overestimated the response value. The sum of the residuals is always 0, and a regression line minimizes the squares of the residuals. The standard deviation of the residuals gives a measure of how the points are spread around the regression line. It is denoted by capital S. And in a residuals plot, the residuals can be plotted either against the x or y values. A residual plot with a definite pattern means a non-linear model will be a better fit for the data. So you need to remember all this in problem solving. So what do each of the residual plots indicate about the linear model? So here there is no pattern here, so a linear model is appropriate. Again, we have a graph of the residual and the variable. Here there is a strong pattern, so a non-linear model will be a better fit. And here there is a pattern for the lower values of x. So we can say that a linear model would be a better fit for small values of x. So basically, when there is a pattern, you have a non-linear model. When there is no pattern, it will be a linear model. Okay, coming to the next question. We have the mortality rate and the latitude, we have the scatter plot, and we have the residual also. Identify the explanatory and response variable. So latitude is the explanatory variable and mortality rate is the response variable because mortality depends on the latitude. Describe the relationship governed by the scatter plot. So there is a moderate negative relationship. It's going down from left to right. So there is a moderate negative relationship between latitude and mortality rate. Does it appear that a line is an appropriate model for the data? There is no apparent pattern here in the residual plot. So you can say that in the residual plot there is no apparent pattern. So a line will be an approximate model. If the latitude is minus 5.9776, what is the slope of the regression line and what does it signify? Slope of the regression line is minus 5.9776 if the latitude is minus 5.9776, and it means that each unit increase in latitude is associated with a 5.9776 decrease in mortality. Decrease because it is negative. Is there a cause and effect relationship between mortality and latitude? There is correlation between mortality and latitude but no cause and effect. You cannot necessarily say that latitude causes mortality. Correlation does not cause causation. One of the regions had a latitude of 39 and a mortality rate of 162. Calculate the residual for this point and interpret it. Your constant is 389.19. So mortality will be use the formula A plus Bx. So A is 389.19. The mortality rate is 162, latitude is 39 and slope as we have seen earlier is 5.9776. So it will be A is 389.9 minus 5.9776 into latitude which is 39. So that would be 156.06. This is a predicted value. The actual value is 162. So residual is actual minus predicted, that is 162 minus 156.06 which is 5.94. So that means the mortality rate is 5.94 more than the predicted rate. If R squared is 68%, interpret the coefficient of determination. So coefficient of determination is R squared is 68%. So again it implies the same thing, that 68% depends of the mortality rate depends on the latitude. What is R, the correlation coefficient? R is square root of 0.68, so that will be minus 0.825. R is negative because the slope is negative. Interpret the statement S is 19.115. S is the standard deviation of the residual, so it shows how the data points are spread along the regression line. So the standard deviation of the residuals is 19.115 here. Now coming to regression outliers. In a scatter plot, regression outliers are points deviating from the pattern. So there are two regression outliers here. And in residuals, a point is an outlier if its residual is an outlier in the set of residuals. For instance, you can see this graph, R's on social media and GPA. There's a scatter plot. A and B are outliers. An influential score is a score whose removal would sharply change the regression line. And an outlier in both the x and y directions will result in roughly the same slope, but the absolute value of the correlation may increase. So I'll stop here for now. We have learned about scatter plots and how to interpret them, and a basic idea of outliers and regression plots. Thank you and stay tuned in.